Hopefully and wishfully, you are all okay and listening to me properly. Our today's topic is ECG, which stands for electrocardiogram. You know that heart is pumping blood into the arterial system, and for that it has to contract. And for the contraction, it has to be stimulated by an impulse. You also know that the generator of that impulse is situated in the right atrium, which is called sinoatrial node. From there, the impulse originates and it spreads over the whole of the atria. Then it comes through special pathways, that is the conducting tissue, into the ventricles, and the ventricles then contract synchronously to push the blood into the aorta. Now, when this impulse propagates inside the musculature of the heart, it also propagates in the surrounding tissues which surround the heart. That's the lungs, the blood vessels, the muscles, and the skin even, skin of the chest and skin of the body. And you are picking those electrical stimuli with the help of an ECG machine and record it over the paper. This is called ECG. It is also called EKG. Previously, people used to say EKG rather than ECG. Even nowadays, some physiologists and physicians use the word EKG, so both are correct. The electrical impulse travels to the skin, and the recording made over them is the electrocardiogram. Now you have to differentiate between these two words. Electrocardiograph, as it should have been that graph which we take on the paper, but it is opposite. Electrocardiograph is a machine, and electrocardiogram is the ECG recording which we take on the paper. So this is the difference between these two. Electrocardiograph is a machine. It is recorded with the electrodes attached to the skin of the person or the patient, and they are then connected to the electrocardiographic machine. These are called leads. And the recording which you get over the paper is also called lead. ECG previously used to be a very laborious work. Huge machines used to be used, having more weight more than 700-800 kgs, not portable at all. The patient used to sit in the chair with all the four limbs dipped in drums of solution, which worked as conductors. But nowadays, ECG has become very easy, and it's a bedside procedure even. A small ECG machine of the size of the computer that is taken to the bedside of the patient, and the ECG is recorded there and then. Thanks to the engineers, they have devised very specific and easy to handle machine. As I told you, when you record the ECG over the paper, it has got multiple waves, some up and some down from the starting point. Mainly, you can see P wave initially, followed by QRS complex, and followed by another wave that's a T wave. Sometimes after T wave, there is a U wave as well, but that's not your concern, at least at this point. These are actually waves of depolarization and repolarization. Now, by now, you also know what is depolarization and what is repolarization. Depolarization cell normally is in a polarized state, which means it is having positive charge over the membranes outside the cell and has got negative charge inside the cell. This is the resting state of the cell, which we call polarized cell. When it is depolarized with the stimulus, the ionic change is reverse. That is, outside becomes negative while inside becomes positive. And this propagates ahead till whole of the cell is depolarized. And once it is depolarized completely, then there will be no flow of current. So if you are recording it during depolarization, when the needle goes up to mark an upward wave, on the completion, it has to come back to the normal resting level. That's the baseline. This is called depolarization. And remember, after depolarization, cell automatically has to become repolarized. It has to gain its normal position once again to get prepared for another depolarization wave. And during repolarization, once again the impulse starts flowing and it is recorded over there with the help of the electrocardiographic machine till the whole of the cell gets repolarized. Then the baseline is, the needle comes to the baseline. This is the depolarization with the stimulus, reversal of the positivity and negativity, and then automatic repolarization to gain health once again. Now this is a pattern of the ECG, which you record over the paper. From left towards the right, you started from the left side, there is a P wave. It is followed by a small downward deflection, which is the Q wave. Q wave goes up to become an R wave, which then comes down to become an S wave. And the S wave once again goes up till it finishes at the baseline when another wave, the T wave, starts. So P wave, the QRS complex, that is actually one complex, and then the T wave. Now the P wave is the wave of the atria, the upper two chambers of the heart, which are weak. Anyhow, they have to be stimulated because contraction is also needed in the atria, and that contraction pushes the last 20% of the cardiac output to the ventricles. 80% of the blood from the atria comes to ventricles without any atrial contraction. As such, it is coming from the veins into the atria and from the atria into the ventricles. But ultimately, the last 20% of the blood has to be ejected into the ventricles by the atrial contraction. An atrial contraction occurs at the end of the P wave. What I mean by this is that first of all, when atria are stimulated, the impulse spreads over the atria, and that spreading of the impulse gives you the P wave. And once it is completed, it is followed by mechanical contraction. So you can be asked at which point the atria contract in the ECG, then it should be at the end of the P wave. Your answer should be at the end of the P wave, not the start of the P wave or the middle of the P wave, but it is at the end of the P wave. So first there is electrical change, and then there is a mechanical change. Electrical change is the appearance of the wave, and mechanical change is the actual contraction. It is always in the same way in other complexes as well. For example, the QRS complex, which is the complex or wave of the ventricular contractions, but the ventricles contract at the end of the QRS. First the QRS appears and then the ventricle contracts. In this way, when we go along the T wave, that appears, but it is the wave of repolarization. So once again, I started from the start. P wave is the wave of depolarization of the atria. QRS is the wave of depolarization of the ventricles. T is the wave of repolarization of the ventricles. Now, a question should come to your mind. The ventricles contract, they depolarize and then contract and then repolarize and get the T wave. Why there is no repolarization wave of the atria? P is the depolarization wave of the atria, but they should have a wave of repolarization as well, and it is there, but it is submerged in the QRS complex because it is the time of atrial repolarization when the ventricles depolarize. So ventricles, they are powerful and they get their wave. And you can say that the atrial repolarization wave or the T wave of the atria is submerged in QRS complex because their timing is the same. So it is not visible. You cannot see the atrial repolarization wave. For recording, somebody is using pen over the slides. Just starting the slides, please. Now, as I told you that the patient has to be connected to the ECG machine through wires which are called leads, so that the electrical impulse which has spread and reached the skin, that should be transmitted to the ECG machine through these wires. The bigger the muscle fiber, the bigger is the voltage. Voltage is actually the strength of the ECG wave. It is measured from the top to the bottom. For example, from the top of the R wave to the bottom of the S wave. This is the voltage of the ventricles. Similarly, the height of the P wave will show the voltage of the P wave, which is because of the atrial contractions. Obviously, ventricular muscle is too much thick and bigger as compared to the atria, so they get the major share in the voltage. As I told you, ECG nowadays has become very easy. It's a bedside procedure. And the machines have been designed such nicely that you need not connect various parts of the body manually to the various parts of the ECG, to various buttons of the ECG. But you just touch one button, automatically all the connections are connected of that very lead. You touch another button and then you switch on to another position where the connections become different. P wave, as I told you, is a wave of atrial depolarization. It is DEP, not DAP. P wave is the wave of depolarization of the atria, occurs at the beginning of the atrial contractions. At the beginning of the atrial contractions. QRS occurs at the beginning of the ventricular contraction. Means first the wave has to be formed, followed by mechanical contraction. T wave is the wave of ventricular depolarization, and I discussed now that where is the T wave of the atria that is submerged in the QRS complex because of their timings, which are the same. That's why atrial depolarization is not visible. Now, once you have recorded this P, Q, R, S, T waves over the ECG paper, you look at it, there you can see some intervals, and intervals mean from one wave, the timings are the distance from one wave to the start of another. So this is the interval. For example, interval, PR interval, it is from the start of the P wave to the start of the QRS complex. Look at the diagram once again. From the start of the P wave, from left side you can see there's the first is the baseline, and then the dome of the P wave starts. So this is the start of the P wave. From here up to start of the R wave. Start of the R wave can also be a Q wave, but in some ECGs, normally Q wave is absent, so we are talking of the R wave then. That's why the name of PR has been given, not the PQ. Now this takes some time in the formation of the PR interval. Then there is another interval which is QT interval, very important. It is from the beginning of the Q wave to the end of the T wave. And you will later know that this is the time when the ventricles contract and relax. And you know that it is actually the ventricular contraction and relaxation which is very, very important for the normal cardiac output. If this is disturbed, the ventricles are disturbed during contraction, or the ventricles are disturbed during relaxation, then the cardiac output will suffer a lot. And once the cardiac output suffers, then whole of your tissues, starting from your brain, that is affected because it is not getting proper cardiac output, proper blood supply. So this QT interval is important in a sense that heart should not be disturbed by any stimulus during this time. And QT interval should be normal. If it is prolonged or if it is shortened, then it can make the ventricular contraction difficult. Nowadays, you might have heard that for the coronavirus, some physicians advocated the use of hydroxyquinoline, but the drawback of the hydroxyquinoline is that it disturbs the QT interval. So most of the physicians do not recommend it. They warn us to be cautious and not to use the hydroxyquinoline because it disturbs the QT interval. Then another study shows you some segments. Segments are shorter as compared to the intervals. PR segment is from the end of the P to the start of the R. You know it now that PR interval is from the start of the P to the start of the R, whereas PR segment is from the end of the P, it excludes the P from it. It's from the end of the P to the start of the R. This small segment is called PR segment. Similarly, ST segment from the end of the S, when the S wave ends at the isoelectric line at the baseline, and then the T wave has to start. So from the S, end of the S to the start of the T wave, this is the ST segment, and this is also very important. Almost in every ECG you record, you look for the ST segment. It should ideally be at the baseline, at the zero line, not neither up nor down, this segment, because whenever ischemia of the heart occurs, ischemia means deficient blood supply to the heart. Whenever ischemia, जिसको उर्फ आम में हम heart angina भी कहते हैं या heart attack भी कहते हैं, when the blood supply gets decreased to the heart, this ST segment goes up or goes down, and it changes its original isoelectric point. So this is important in this way. Similarly, the T wave in certain ischemias that also becomes inverted. But this is actually another topic. If we find time, we will discuss it, inshallah. Now look at this diagram. P wave, start of the P wave, then the completion of the P wave, then the PR segment goes till Q starts. Now from here, start of the P wave up to the start of the Q wave, this is the PR interval. It tells you the timings when the cardiac impulse is traveling through the atrioventricular bundle or bundle of His. When it shortens, for example, in tachycardia, and it becomes longer, the PR interval in conditions of blocks, which we shall study later. Then you look at the end of the P wave and the start of the Q wave, it is a PR segment. I told you earlier that segments are smaller. Intervals of yaad rakhein, intervals are bigger as compared to the segments. Now, the PR segment is from the end of the P wave to the start of the R wave. ये फर्क जान लें आप PR इंटरवल जो है from the start of the P है और PR segment from the end of the P है. Then the QT interval you can also see it is from the top start of the Q wave up to the end of the T wave. It includes whole of the QRS complex and the T wave as well. Remember, this is the whole time when the ventricles contract and relax. When they contract, they push the blood into the aorta and they get empty. And when they relax, they are refilled. So this is a part of the cardiac cycle. QT interval, as I told you, is very sensitive and it has not to be disturbed to avoid any ill health of the ventricles. Now, P wave, as you know, is because of the atrial conduction of the impulse to the atria. I won't say it is because of the atrial contraction, because the actual point is the contraction appears later when the P wave has already been formed. Anyhow, we know that it is related to the atria. So any atrial pathology will affect the P wave. For example, atrial hypertrophy, when the blood from the atria cannot be passed properly and easily from the atria to the ventricles, there is some constriction in the valves, then the P wave will be disfigured. But since we are not much worried about the atrial contractions, as I told you earlier, that atrial blood, 80% of it comes by itself without any atrial contraction. It is the only last 20% of the atrial blood which has to be pushed into the ventricles through atrial contraction. So even if that is not available, one doesn't become that much ill unless you do strong exercises where you need the last 20% atrial blood as well for the cardiac output. So in all the conditions in which the atria are diseased, then the P wave will have changes in it. Sometimes the atria are unable to contract. For example, atrial fibrillation, they only fibrillate, there is no actual contraction. So in those cases, there will be no P wave, which proves that P wave will only be there if the ventricles, if the atria can contract. Then we come on to the QRS complex, which is because of the conduction of impulse to the ventricles, followed by ventricular contraction. So whenever the pathology in the ventricles occur, we will get changes in the QRS. That will be, for example, bigger of high voltage if there is ventricular hypertrophy. Enlargement of the ventricles is called ventricular hypertrophy. And it will be bizarre with wide open waves. That might be the Q wave or the S wave, R wave. They are wider than the normal if the flow of the current through the ventricles is difficult. For example, there are some blocks in it, and the impulse cannot pass quickly from one point of the ventricles to another. Then in that case, you will have a bizarre white QRS complex. ECG is helpful in many diseases. For example, it tells you the rate, whether the heart is beating at the normal rate or it is beating at a higher rate, which we call tachycardia, or it is slower than the normal, meaning below 60 beats per minute, which we call bradycardia. So it tells us the rate. ECG tells us the rate. Next is the rhythm, whether the heart contracts rhythmically or there is arrhythmia. Arrhythmia means some of the contractions occurring early, some late. So the rhythm disturbs. Then it also tells the axis. The axis के spelling गलत है, AXIS. Axis वो होता है जिसमें we determine the main flow of the current flowing through the heart. So this has to be discussed later on. Then another point is that ECG tells us hypertrophy. ये hypo नहीं है, hyper, enlargement of the chambers, enlargement of the muscles of the heart. For example, the left ventricle enlarges in case of hypertension. The right ventricle enlarges in case of pulmonary hypertension. So in such cases, the voltage will be high. And most important, it tells the condition of the blood supply to the heart, condition of the blood supply to the heart, whether that is compromised or not. If the blood supply is not proper, it is less, then the heart is said to be ischemic, less blood supply. And one feels pain in the chest in the form of angina, particularly when undergoes exercise. So in such cases, the ST segment, which we discussed earlier, that will be either down or slightly up from the baseline. The ST segment changes its position. Similarly, T wave also may get inverted. This is the ischemia which we can detect with the help of the ECG. So if you look at it, the list, once again, there is a mnemonic for it, Rahi. Rahi शायर होता है ना कोई. So Rahi आप याद रखें, but with double R. Double R, AHI. First R tells you the rate. Second R tells you the rhythm. Then comes A, axis. Then H is for hypertrophy, enlargement of the muscles of the heart. I is for ischemia, Rahi. So this is a mnemonic for remembering what the ECG tells us. If somebody asks you, what do you know from the ECG? Then your answer should be this, Rahi. Means rate, rhythm, axis, hypertrophy, and ischemia. Now, ECG is recorded on a special paper called the ECG paper. एक बच्ची ने लिखा है कि we don't have ECG paper. I had informed your CR and the engineer host to get arranged ECG papers so that you can understand. Now, if you look at the ECG paper, a special paper over which ECG is recorded, it is round about 2 inches wide paper, which has got vertical lines and horizontal lines. in between vertical lines and horizontal lines, you get squares. If you look at the ECG paper, there are thick lines. What I'm talking now about the horizontal lines, lengthwise आप देखिए. There are thick lines, then there are 4 thin lines, once again a thick line, again thin lines, 4 thin lines, 5th is the thick line, and so on. Then look breadth wise आप देखें from up to down, उसमें भी ऐसी ही लकीरें हैं, lines हैं, thick line coming from up to down throughout the breadth of the paper, followed by the same vertical lines but thin lines, 4 thin lines, then again thick line, and in this way you get squares in between these lines. Now if you look at the thick lines and concentrate only on thick lines, you get a bigger square. But if you look at the thin lines, you get small squares. They are squares, but they are smaller. In every big square, you can accommodate 5 small squares. From left to right or from up to down. When patient ECG is recorded over this paper, and you should also know that the horizontal lines from left to right, lengthwise of the paper, they tell us the timings. ECG paper में timings अगर आप calculate करेंगे, then you have to consider the small lines and the bigger lines lengthwise. From one big line or thick line to another thick line, the time is 0.2 seconds. How much? 0.2 seconds. ये लिख लें आप. Note it down. The timings from one thick line to another thick line is 0.2 seconds. And you know that there are 4 lines or 5 small squares between the 2 thick lines. Now concentrate over the thin lines. Thin lines may be small squares बनते हैं. So the timings from one thin line to another thin line is 0.04 second. How much? 0.04 second. Which means that in one big square, 5 small squares can be accommodated. With 5, the answer is 0.2, which means a big square. Then vertically, if you consider these lines, as you go up or down, from one thick line to another thick line is 0.5 millivolt. This is the voltage. As I told you earlier, that up and down we consider voltage estimation. So from one thick line to another thick line is the voltage is the 0.5 millivolt. So between one thick line then second, and then third line. So between two thick lines, rather three thick lines, your voltage becomes 1 millivolt, means two bigger squares, 1 millivolt. Then we come to the recording of the ECG. How do you record it? If you know it in your lab, ECG machine is available over there, and the connections, etc., will be told there, inshallah. But right at the moment, you should know that conventionally we record 12 lead ECG in the following manner. ECG recordings are the leads printed over the paper are of three types. Standard bipolar leads, which are 3 in number. Second is the augmented unipolar leads, which are also 3 in number. And lastly, the chest leads, which are 6. So in total, 12 lead ECG is recorded in this way. First 3 standard bipolar leads, next 3 augmented unipolar leads, and lastly 6 chest leads. Now, if you look at this diagram, when you connect right arm and the left arm with the ECG machine in such a way that right arm is connected to the negative terminal and left arm is connected to the positive terminal, you record an ECG and you get a pattern which we call lead 1. You can see over the neck of the diagram is the lead 1. So this is a connection between the right arm and the left arm with the machine. Then you connect right arm with the left leg. You call this lead 2. Right arm, which is negative, and left leg, which is positive. So you should also know that right arm will always be negative whenever connected during ECG. It will always be negative. And left foot is always positive, while the left arm is sometimes positive and sometimes negative. When it is connected with in L1, then it will be positive, but in lead 3, which is between the left arm and the left leg, that is lead 3, then the left arm will be negative. So right arm always positive, negative, left leg always positive, and left arm changes. In this way you record. Now you need not to connect everyone to the special points. ECG machine has been designed in such a way that you just push or touch one button, the connections are made through by themselves. In this way you record, these are called lead 1, lead 2, lead 3. These are the standard bipolar leads. Bipolar means when the two limbs are used in it. Just a right arm and left arm in L1, right arm and left leg in lead 2, left arm and left leg in lead 3. Then we come to the second portion, that is the augmented unipolar leads. Augmented called in a sense that they have been augmented. When first they were recorded, due to the positions, the recording was used to be very minute and difficult to read. So some mechanism has been produced in the ECG machine, which augment these, which enlarge them. That's why they are called augmented unipolar leads. यहाँ पे unipolar लफ्ज इस्तेमाल हुआ है, which means that the two limbs you make one and then use another limb, the third one. So two limbs are connected to the negative terminal or they are made zero. And you are left with one limb which has to be connected to the positive one. Now, if the positive one, the name goes after the positive one. If the positive point is connected to the right arm, you get AVR. AVR is written in this way. A small, capital VR. It becomes AVR. What is AVR? When you connect positive terminal with the right arm and the left leg and left arm, both are connected together and then connected to the negative terminal of the machine. So it is called AVR. The name goes after the positivity. Left arm पे अगर आपने positive रखा, this means you are connecting right arm and the left leg to the zero, to the negative. So you are left with the positive which is placed over the left arm and you record AVL. Similarly, if the positive electrode is connected to the foot, left leg, and the two arms, right arm and the left arm, they are connected to the negative terminal, connected one lead and then connected to the negative, then we get AVF. In this way, we record AVR, AVL, and AVF. Now we are left with the chest leads in which all the three leads, that is the right arm, the left arm, and the left leg, they are connected together and they are made zero. They are connected to the negative terminal. You are left with the positive, and now you look, all the limbs have been used. Where to put the positive? The positive is put over the chest. The positive is put over the chest, and that's why we record the chest leads. Now, if there are, as I told you, 6 leads, now look at this diagram. V1, the chest leads are designated by V. So V1, red आप देखें, which is placed over the right of the sternum in the 4th intercostal space. This is the 4th intercostal space just to the right of the sternum. Then the yellow is the V2. That is opposite the mirror image of the V1, means the same 4th intercostal space, but on the near the left border of the sternum. Then forget about V3 now, jump on to V4. It is in the 5th intercostal space in the mid-clavicular line. ऊपर देखें line, clavicle के mid से pass हो रहा है. So you put the electrode over V4 और V3 पे आ जाएं, so it is midway between V2 and V4. Midway between V2 and V4. Now coming back to V5, it is the same 5th intercostal space, but in the anterior axillary line. By now, you should be familiar with the axillary lines, anterior, middle, and posterior through your anatomy. So anterior axillary line में V5 होगा और mid axillary line में in the same 5th intercostal space V6 होगा. अगर आप इसको देखें, V1 and V2 are in a straight line. Then V2, V3, and V4 are in a straight line which is inclined downwards. And then V4, V5, and V6, they are in the same plane but going back. In this way, you record the chest leads. Since The chest leads are very near to the heart, so they are more conspicuous and more bigger as compared to the limb leads. We look at the ECG for different diseases. Some can be easily seen in the chest leads, some can be easily looked at the limb leads. So different leads tell you the different positions. And with this, we finish it. I'm sorry, no time has been left for the questions. Anyhow, if engineer allows it, if he has got time, I am ready to answer.